Hello, Hornets. Welcome back. We're going to be taking a look at our basic derivative rules. And from these basic derivative rules, we will then combine them and expand them to take a look at the more complex rules that we end up with. Now, there are a lot of small fish in this water, and then there are a couple of big fish. We call these the sharks in the water of our calculus. So I want you to understand that what I'm going to show you right now are just the basic small minnow fish. They're the easy ones and the things that we really don't stress too much about. So let's start off with the basic rule that says the derivative d dx of a constant is zero. We've seen that quite a bit. We have the derivative d dx of some constant times x. Let's go ahead and change that to a c is just c. And we also know that d dx is 1. Now, keep that in mind because we know this because a dx over dx is 1. And the variables cancel out. Notice dx over dx, very straightforward. Then we have the rule that says if we have a constant in front, we can move that constant out of our derivative in order to find it. Okay. We have our sum that says f of x plus or minus g of x equals d dx of our f of x plus or minus d dx of our g of x. Okay, so these are our first basic ones. Now, we've also seen sine and cosine. D dx of sine of x is cosine of x. And we've seen that the d dx of cosine of x is equal to negative sine x. Okay, so these are our basic rules. These are the ones that we start off with, our fundamentals, and then we throw into it our general power rule. Now, the general power rule is our first rule that really gives us tremendous power to do a lot of things. Okay, so here we have our basic derivative. Now, there are a few more that we need to make sure that we go through and check out. For example, if I am trying to work with the product rule, we started talking about the product rule. And the product rule requires us to do each piece one at a time. D dx of just the first function and then multiply it by the second and then add to it the second multiplied by the derivative of the second. There we go. So that first derivative of the first times the second plus the derivative of the second times the first. Now we often see this using different letters. U times V. Now what we end up with is du dx times V plus u times dv dx, or as some people prefer it, u prime v plus u v prime. Okay? Notice how that pattern works. Now, whether you use all of the letters, etc., it doesn't matter. Okay, just keep in mind, you need to memorize this. Now, in some cases, we just, first times the derivative, first times the second plus the derivative, second times the first. Fantastic. But there are some derivatives that don't go quite so well, and they require us to come up with a little bit of a rhyme. So let's look at the derivative of a complex f of x over a g of x. Now, this is called the quotient rule, and I'm just going to go through it with you. The derivative of f of x times the g of x minus the f of x, let me make sure I keep that clear, times the derivative of the g of x. You'll notice that looks very close to the product rule, all over the g of x squared. Now, I'm going to show you another way. Let's call it d dx of u divided by v. We end up with u prime v minus uv prime over v squared. Now, how are you going to remember that? Well, I've got a little rhyme for you. This is the low part. This is the high part. Okay, keep that in mind. We're going to call this the low d high less high d low, square the bottom, and away we go. Once again, away we go. Now, it's at this point I would make my students say it out loud several times. So if you want, you might want to just talk with me. Low d high less high d low, square the bottom and away we go. Once again, low d high less high d low, square the bottom and away we go. Okay, notice the low value is v, derivative of the high value, less meaning minus, the high value times the derivative of the low value, and then square the low value, and you're ready to go. Alrighty, we're going to be taking a look at some examples of this in the next video. Thank you very much. Have a great day.